Hello, I'm Michael Policio, Field Service Engineer for Cement Test Equipment, and today we're going to be covering some basic maintenance procedures and calibration procedures for the M15-400 contestometer and M15-400GS gel strength analyzer. The first thing we're going to cover today is our slurry plug head, which basically transmits the motor rotation to the paddle. The main problem that we experience out in the field is the failure of this poly pack right here, C-1067. This upper part with the mag drive housing engaged into it has to be charged with oil, otherwise you will experience binding when pressure is placed to the bottom side of the slurry plug. So I'm going to go over how to change this poly pack and an associated poly pack C-1066 on the inside of the head, and we'll charge the head with oil, and then we'll be ready for a calibration. So the first step is to remove the inner magnet, which is accomplished by taking your slurry cup paddle, engaging it in the coupler, holding tension on the magnet as you unscrew the coupler. The coupler is disengaged from the mag shaft. The magnet will simply pull out, and you will see a bearing on the bottom and a bearing on the top. These bearings seldom fail as they are bathed in an oil bath most of the time. The only thing that will really affect these bearings is if you get cement up into the head, they will corrode. To access the C-1066 poly pack, you will need your tool 18-28 spring retaining tool. And the part that you are going to be taking out is the 1826 seal retaining plug. The seal retaining plug is slotted, and the spring retaining tool has these tabs which will engage the plug perfectly. A lot of you will be tempted to use a large screwdriver, flathead screwdriver, to remove this plug, but we don't recommend that because this is a very soft metal brass, and eventually you will damage the plug. So we'll engage the spring retaining tool into the head, engaging the seal retaining plug, and turn counterclockwise or lefty-loosey until the plug is free. After the plug is removed, you'll need a pick to go in through the top and push out the C-1066 poly pack. From the 1066 poly pack, there is also the retaining spring. So make sure that comes out too, or if it stays in, that's fine, but just don't lose your spring. To remove the 1067 poly pack, again, take your pick. If you apply pressure to the side, you'll get a gap on the side of it. You don't have to worry about harming the poly pack at this point because we are going to change it, and merely pry the poly pack off. Our new 1067 poly pack, as you can see, a poly pack differs from an O-ring because it has this brown insert cut into the O-ring. What you need to remember about this is this brown insert always faces toward the pressure. So installing the poly pack, as I said before, the brown insert faces the pressure. Our pressure is going to be coming from the top of the head after we charge it up, so your brown insert poly pack will be facing straight up. And this can be a bit of a bear to get this in. Once you have it inserted into the groove, you simply have to pry it back on and work it around so that you are not twisted. As you can see here, I'm twisted right now. This is the configuration I want to be in, so simply pinch the poly pack and work it around until everything is facing the same way. As you can see, the C-1067 poly pack is installed back on top of the seal plug. As I extrude it out, you can see the poly pack is facing up and everything is uniform all the way around. It's imperative that you do not have this twisted as it seats in the groove. And do not use a pick or anything sharp to reinstall it, as you will damage the poly pack. What we're going to do next is install the C-1066 poly pack with the seal plug retainer back in place. So to reinstall your C-1067 poly pack, the first thing that goes in is your spring. It drops in. Visually verify that your spring is in place. Now we'll insert our seal retaining plug back onto our spring retaining tool. Now we will insert our C1066 poly pack onto the spring retaining tool. And again, the brown insert of the poly pack, which faces pressure, will go against the bottom of the retaining plug. Now you will insert the spring retaining tool back into the plug and screw clockwise until your plug bottoms out. This does not have to be done Herculean tight, just good and snug, and remove the tool. Our next step is to reinstall the inner mag drive, taking care that the threads on the bottom of the shaft do not cut the poly pack that we just inserted. A simple twisting motion as you apply pressure will ensure that the poly pack is not damaged. Now we'll reinstall our paddle coupler using your paddle shaft. You can hang on to the magnet with this hand and screw clockwise until the coupler bottoms out. Okay, now we're ready to reinstall our mag drive housing, starting with your upper bearing retainer. Slides over the bearing, and then we're going to screw our housing onto the plug, making sure it bottoms out all the way. It will be a little tight with the new poly pack, but that's what you want to hold the oil inside of it. What I have here is just your regular mineral oil that you use to operate the instrument. I'm going to simply fill the upper mag housing with oil and reinstall your medium pressure plug into the top of your mag drive housing and tighten with a 1/2 inch wrench. Okay, now that I have my top mag housing charged with oil, I've applied a coat of our C670 grease, which we recommend you use anytime that you have the plug engaged with the slurry cup. I already have my slurry cup filled with oil. You can do this with oil, or you can do this when the next time you run a slurry after you charge your cup. We're simply going to place it in and hook up our tube to it. When you engage your medium pressure tube into the slurry cup head, if you cannot bottom out that plug finger tight, do not put a wrench on it and try to force it in, or you will cross thread the head. Now we're going to pressure up the vessel, and we don't want a lot of pressure here. 80 to 100 pounds is sufficient. We don't want to squirt oil up to the ceiling. After we have pressure on the cell, we're going to open up our mag drive housing plug and make sure there's no air inside. As you can see, the air bled off, and now we just have oil coming out. Tighten the plug, release pressure, and your slurry head is charged and ready for calibration. So the main focus, people, that you want to pay attention to is there should never be any oil sitting on this surface where the outer mag drive housing meets the head. If you see oil there at any time, oil that you did not spill, which you shouldn't do, then you have a poly pack leaking under here. You're losing your pressure up here, and you're going to get erratic BC and gel readings. So now we're ready to do our gel strength calibration. As you can see, I have the motor engaged. The slurry cup is dry, paddle only, head engaged, cable attached to the motor through screw on the calibration arm, and I have 50 grams weight holder plus 50 grams of weight for a total of 100 grams. If you do not have a gel strength option on your machine, please fast forward this video for consistency calibration. We're going to go into instrument setup. Our calibrate list here, we're calibrating gel strength. And we're going to start motor. And as you can see, your motor is going to make 3/4 of a turn, and then it will stop and hold 100 grams. This is where you want to pay attention to your raw value. As you can see, it's fluctuating right now. The trick to the calibration of this instrument is the motor makes such tiny measurements that your raw value will fluctuate at some point. As you can just see, it went from 0.11 to 0.12. The key to this calibration is letting your raw value settle out to one value. This could take up to 10 minutes for the motor to warm up and settle on one value. Okay, now that my raw value is stabled out, I'm going to add 500 grams to the weight holder, and then again you can watch your raw value increase with the additional weight, and again we're going to wait until this value stabilizes. My raw value has stabilized to 0.47. If you personally are having problems getting your raw value to stabilize to one value, the last section of this video will cover reinstalling your MIT system files, which should be the solution for that problem. Our next step is to lift the weight off of the motor to where you have no torque on the motor at all. You will watch your raw value fall, and when it stabilizes to the bottom end, we're going to save that low value that's automatically entered into your green box there of 0. And my raw value is 0.06, and we're going to save that for 0. At the completion of that step, we're going to reinstall the 600 grams. Our raw value will go up, and it should match what you had when you were letting the initial 600 grams stabilize to one value. That should be the value you're looking for. In my case, it was 0.47, and I am at 0.48, stable, and we're going to save the pre-entered 600 grams. After we've entered our low and high values, your calibrated value shown here in the green box, you want to make sure that that number does not stray plus or minus 25 from the 600. You will see it fluctuate above 600 and below 600, but never more than 25. As long as you have a fluctuation above and below the 600, you will never read a steady number on here. You'll know your calibration is good. After you're satisfied you have a good gel calibration, be sure to support your weights. Hit your save button, and again you'll be prompted to save. Switch your motor to stop, supporting the weights, and that completes the gel calibration. We're now set up to do calibration of consistency. As you can see, I have the motor attached to an empty cell, paddle only in the pressure vessel, head engaged, cable on the calibration arm, and we're going to start with 100 grams of weight. If you did not do a gel calibration before you started your consistency, then we recommend before you set up here to energize the motor and let it run for a minimum of 10 minutes, as the calibration works better after the motor is warmed up. Going to instrument setup, we're going to be calibrating consistency, starting with 100 grams, and we have 9 BC already pre-entered into the box. We're going to hit start motor. This works on an average. The longer the motor turns, the more accurate the calibration. Do not enter anything you see before it makes at least one turn or one revolution, as most of those numbers will be junk. Again, what you want to look at is your raw value. When it steadies up to one number, then you know you have a good calibration. And we're going to save the low value. Get ready to support the weights, stop motor. Now that we have our low value calibrated, we're going to add 500 grams of weight for a total of 600. Start motor and let the motor wind the weights up again. If you look at your raw value, it's all over the place until it makes at least one revolution of the mag drive. After the revolution, you'll begin to see the raw value settle into one value, and that's the value you want to capture for your consistency calibration. Save, stop motor while supporting the weights, or you will be chasing these weights. And now we're ready to verify calibration. I have a total of 400 grams on my weight hanger, and we're going to start the motor, look at our calibrated value box. Again, pay no attention to the values until you have at least one wind on the motor. And our calibrated value should read 47 plus or minus 5. As I mentioned earlier in the gel strength calibration, if you're having problems getting your raw value to settle on one value, Then you can reinstall the Mint system files on here. For those of you on the consistency portion of this, I didn't mention this, but if you cannot get a good calibration, this would apply to you also. Mint system is the software that controls the motor. And these files over a period of time get corrupted. So you can reinstall those files through this procedure. To reinstall the Mint system files, you will be exited out of your Cement Lab software onto your Windows desktop. Hit the Windows button, All Programs, Mint Workbench, and the Mint Workbench again. And that brings you to this screen. All your projects will have the same name, 1500 USB. So double click on that, and it will bring you to your auto-tune screen. We're going to go to Tools, Install Mint System File. Select your Microflex E100, open, and this goes really quick. Successfully installed. Back to the toolbar, download firmware. Again, select your Microflex E100, download to controller, and it's going to warn you that you're going to do away with your old. Do you want to continue? Yes. And this a little bit longer than installing the system files. So still downloading the firmware here. Like I said, this takes a little bit longer than installing the Mint system files. Okay, after the firmware is downloaded, it will ask you if you want to reset the controller. And yes, we do. Make sure your Connect Automatically box is checked as on this screen. And that way it will prompt, you don't have to worry about connecting the motor yourself. The software will take care of it. It will detect the device after it can communicate. That completes that part. Back to the toolbar, parameter table, and download. And don't blink or you'll miss this. Open, done. That brings us to the auto-tune function of the motor. For your auto-tune, you want to make sure the only box you have checked on here is test the feedback. So uncheck everything else, as you can see. Only the test the feedback box is checked. Start, it will prompt you to tell you that the motor is going to turn. This thing's not going to spin at any high speeds. Select yes, and if you watch the motor, you're going to get rotation in one direction, followed by rotation in the opposite direction. And then you'll get some information down here which is you don't need to know. The only thing you need to watch for is this right here, no errors. As long as that box is green, then the motor has been auto-tuned. You can close out of the window, save current project, yes. And that completes the reinstalling of the Mint system file. If you would like a PDF of this procedure, it is available upon request from the contact info listed on this video. If these maintenance and calibration procedures are carried out regularly, it will ensure consistent and accurate readings of both BC and gel for the lifetime of this instrument. Thank you.